All right, everybody. So in the video that I just made, I explained what an alternating series was and how do you know if an alternating series converges. All right. But I want to take a closer look this time in this video about what that looks like if an alternating series converges. Okay. So that would be the main idea of the video, and here's the problem I want to show you that actually is an alternating series. But I thought it would be good to start by just saying, well, what does it look like when a series converges at all? Like, as far as series that we've already seen, what does it look like if they converge? So I take this series that I use all the time. This is a real simple series. It's a geometric series. I've used this in so many examples, and I just want to show you here real quick just so you can think about it before I show you an alternating series. Okay, so here's a series. This series converges to 1. What does that look like? Or what do we mean when we say it converges to 1? Well, you can look at the partial sums. If you add the first two terms of the series together, meaning you take 1/2 plus 1/4, you'll get the second partial sum, S2, and that will be 0.75. If you add the first three terms of the series together, that would be 1/2 plus 1/4 plus an 1/8. That would be the third partial sum. You'll get 0.875. Now let's say you keep going. The more terms you add, the closer you're going to get to 1 if it converges to 1. So I could write the partial sums down for you. I could say, look, if I add the first 6 terms together in that series, I get 0.98. I can also graph them if you're visual, right? So you can kind of see that these are the partial sums, and the more terms I add together, the closer the grand total gets to 1. I mean, I'm never going to get to that line, and I'm definitely not going to go above it. But the more terms I add, the closer I get to 1. So I've got myself a pretty good scale here. It's not totally accurate, but that is what it's going to look like. All right, very gradually the terms, the partial sum is going to be closer and closer to 1. So that's what you're seeing in this picture. Okay, now that's what it looks like when this ordinary series converges. What does it look like if an alternating series converges? It looks a little bit different. Okay, so here is an alternating series that is also a geometric series. Okay, so I can tell you that this series converges to, what was that formula for the sum of a geometric series? It's the first term over 1 minus r. The common ratio of this geometric series is -1/2. Okay, any term of this series times -1/2 will get you the next term. So it converges to 2/3 or 0.6 bar. All right. So let's see what that looks like. What's it going to look like if you're going through the series and you're subtracting and you're adding and you're subtracting and you're adding, and you just keep that up? What does it look like with regards to this number that the series converges to? Well, so here are some partial sums. If you add the first two terms, what would that be? 1 minus 1/2. There's the first two terms. Your grand total will be 0.5. That's too low. Converges to 0.6 bar. If you add the first three terms, you'll get 0.75. That's too high. It converges to 0.6 bar. If you add the first four terms, 0.63. That's too low. So what will happen is, like this one, the more terms you add, the closer you'll get to 1. The same thing is true here. The more terms you add, the closer you're going to get to 0.6 bar. But as you go through and add, because you're adding, then you're subtracting, then you're adding, then you're subtracting, you'll find that here's how you get closer. You're too high, then you're too low, then you're too high, then you're too low. And every time you add or subtract the next number, you are alternately too high or too low. So here's what the partial sums look like. I'm here, then I'm here, then I'm here, and here, and here. And I'm getting closer to that number. It converges to 0.6 bar. But I'm getting closer to it by being too high and too low in alternate fashion. So the partial sums just jump around on either side of this. That's what it looks like when an alternating series converges. All right. Okay, so I mean, it's a series converges, it converges. Bottom line. Here's what it looks like if it's not an alternating series, this or something a lot like this. And here's what it will look like if it is an alternating series. Just remember that the more terms we add, the closer we're going to get to whatever it converges to. But we're gonna jump around like that. We're gonna be too high, then too low, etc.